building with bamboo, about sustainable design, or you just love learning how to build beautiful things from nature, I guess you are in the right place. So welcome to Bamboo U. My name is Luis, and today we are gonna dive very deep. So literally, we're diving deep into the ground because our topic is foundations for bamboo buildings. So for many years in Bamboo U, we've been sharing what we have learned about bamboo construction. We've shared that in person, we've shared that online, and now we are sharing it also here in YouTube. So this channel is where our community grows. So if you're ready to learn, build, and be inspired, tap the subscribe button and join us. So now you might be thinking, foundations, really? Isn't that the boring part? But well, let's put it this way. A beautiful bamboo structure without a good foundation is like an elephant um, standing on jelly. So it might look okay at first, but something's going to move eventually. So think of a foundation as the boots of your building. It connects your bamboo structure to the earth. It keeps everything in place when it rains, when the wind blows, or when the soil shifts. So it's just like a tree. It needs deep roots to stay strong and stable. So a bamboo building needs a solid foundation to stand very proud. So in this session, we'll show you the most common foundations that we have been using here in Bamboo U in all our projects. So we will break it down in a clear way, in a very non-technical way, so anyone can follow along. No need to be an engineer, no need to be an architect. We're just going to explain everything in a simple way with some sketches, with some 3D models, and with some photos. So I like to think about the foundation as a cake. So use layers as a cake. Imagine that you're just having a slice of that cake, and then we're going to start understanding the anatomy of a good bamboo foundation from the bottom to the top. So let's go step by step through the parts of a good foundation from the ground up. You can see here, this is one of the foundations that we just did last year in December. We started the back of house. You've seen some other videos here when we were building that building. We were showing what to build. We were showing 3D models. We are releasing also some details and animations in terms of foundation and how we build this column. So how does this foundation works? What's the anatomy behind this one? So if we go from the bottom top, you will start having a drainage base. So this drainage should be gravel, should be some rocks, just to maintain like all the water that can come down, it can drain. Then you will have a blinding concrete, that's optional. That's like the smooth concrete base. So then on top of that, you will put the structural footing as the real base, as the real concrete thing that will hold the entire structure. After that, you're gonna put a crowning stone that will help as a moisture barrier. So you will see that in most of our projects, we have that stone that it not just help aesthetically, but also works as a moisture barrier. Think that the bamboo will keep absorbing a lot of water, so then that stone will help to avoid that going up. Then if we look at another detail, you will need to have the connection system that will be a bracket, it will be a rod, or some other element depending on the column and depending on the project that you're working on, it will be different. Here we are using this rebar that goes from the foundation going up, and then that's the way that we can tie the bamboo to the foundation itself. Important thing to consider is that the bamboo is not embedded, it's not inside the concrete itself. The concrete is sitting on top of the crowning stone, and then that way it seems that it's like just fitting, it seems that it's just going inside the stone and then going up and carrying the entire building. Then that's the bamboo clump and some cladding or some finishing if you want to cover the entire foundation. So those are the elements, and those are the particularly the elements that you want to see and you want to look at in your foundation. Most of them, they work similar. Sometimes you can have some brackets made out of steel for split and laminated arches. I will show you later some pictures of how we do that. And also something important to mention is that for a professional and more complex project, it's mandatory or it's highly recommended that you hire a structural engineer. So what we're gonna learn today is something that you can do by yourself, something that you can do at home, and it's not a very complex structure. It's just like 1 story high, or maybe we're just looking at just a pavilion or just a simple roof. Because if you hire a structural engineer, what he will deliver, it's something like this. So this kind of elements and this kind of drawings, as you can see, they are showing exactly all the information needed for your foundation. But if we try to dissect the same drawings as the anatomy that we were explaining earlier, then you will see that the elements are exactly the same. You start with a footing, you start with some drainage and some soil improvement, then having your concrete footing, a crowning stone, and then how the bamboo will be connected to the foundation by a rebar or a rod or a bracket. So again, try to hire a structural engineer if you're working on a more complex project. So the ground rules everything. And what I mean with that is, think that if you build on a soft or wet soil without preparation, without any soil improvement, it's like um, it's like planting a post into a birthday cake. So it will going to sink. Every building sinks, but don't tell this to your clients. Foundations will help to make the building sinks evenly over the years. So every single year or a couple of years, like a couple of millimeters, the building will start sinking. So because you have this footing and you have like this big thing of concrete, the building will start sinking evenly because all the footings should be also connected. So if you want to think about the soil and how to define if your soil is good enough to hold a building, I have a tip for you. Start digging a 50 centimeters hole and check if the soil is firm and dry, and it's very dry. So what you would like to do, imagine in a section you will have the floor here, and then you want to go deep 50 centimeters. Let's think that you will divide, and all of this is soil. You want to see like some layers in the soil, how they behave, how they perform. If you start digging here 50 centimeters, then the ideal thing is that you hit solid rock here. Then you will start looking that the rest of the layers are getting softer. Important thing is that if it crumbles or if it's filling with water, then you will need to work on a better base or a different foundation type. So the best way is just to go and find solid rock. So how to, in terms of the ground, there's like 3 different kinds of soil. So once you start digging, you might find 3 different soils that can hold different amount of weight. So just to give you an example how much weight can hold or can bear a soft soil, let's say that just a soft soil can get like 50,000 kg per square meter. Then a medium one can support around 100,000 kg per square meter. And then a hard soil, which is the one that we're looking at and the one that you would like to have, it's 200,000 kg per square meter. That's just to give you an idea of how it can work. Now, let's think about precising your foundations. And I will give you a rule of thumb because we're not calculating now as real engineers, as a professional project, but something for you to have in mind to be safe in the projects that you will be working on. So again, before you dig or pour concrete, it's important to precise your foundation. So a quick way to make sure it's safe and it's strong enough is this simple rule. Estimate the load on each column, all the load that can carry and that will bear each column. That's the structure plus the roof, plus the people, plus the furniture. I will explain you how to calculate that load, so don't worry. Think about all the loads that one single column will bear, and then just to be safe, multiply it by 3. Very easy. So, for example, if a column can support 300 kg, the foundation should be at least 900 kg. It needs to support 900 kg. We are calculating and we are estimating that the column will support 300 kg. Again, I'm going to explain you later how you're going to get to that number. So just as a rule of thumb, a basic reinforced concrete footing that is 40 centimeters by 40 centimeters and a depth of 60 centimeters, one concrete footing that way with a normal 150 to 200 kg in terms of the concrete, of the specifications of the concrete, it can hold 900 kg or it can hold up to 1,200 kg. So this foundation that we are looking at here, 40 by 40 by 60 centimeters, is good enough, and I can assure that this kind of foundation and this kind of footing is good enough for you to start safe, and it's a good and safe place to begin. Now, how to calculate and how to precise all the loads. So dead loads, live loads, and roof load. We have many different things of how to calculate. So we have dead load. The dead load is the permanent weight of the structure itself. It includes bamboo beams, it includes flooring, it includes ceiling, roof frame, etc. So all the permanent elements are going to be the dead load. So that will be around 20 to 50 kg per square meter. That's a basic rule of thumb for you to get that. Now, live load. The live load is the people, is the furniture, is what is using the space, and we have a couple of elements. You can think about 100 kg per square meter for residential projects, or for heavy use projects, you can just double that to 200 kg per square meter. Workshops, dancing floors, storage, yoga shalas, etc. So again, that's only the live load that is applying weight to the entire structure. Think about just one floor or one story high construction, then all the elements that are live loads are going directly to the soil, and they are not particularly getting the weight from the columns. Then The third load that you want to look at is the roofing. So roofing materials can vary its weight. So you are gonna look at the roofing material, the trusses, if you're using bamboo shingles, clay tiles, copper, asphalt, whatever material you're using. So just to give you an example, if you are using a lightweight bamboo roof, such as thatch roof, alang-alang, or palapa, or just grass roof, it will be around 15 to 25 kg per square meter. That way, knowing the size of your roof and multiplying that times 15 up to 25, then that's the amount and that's the load that will be part of the roof floor. Now, if you're looking at, for example, clay tiles that are heavier, and if it's raining, it holds and absorbs a little bit of water and it gets heavier. So let's think that clay, that can be up to 40 and maybe 60 kg per square meter. So now you have the first load, second load, live load, and the roofing material. Then what you want to do is add them all. So let's say now that you have that you want to design a bamboo pavilion or just a small shelter that maybe your floor area will be around 80 square meters because you have a nice plot. I'm just gonna do like a square, and then you want to do a pavilion that has somehow a leaf shape. So as a top view, you're gonna look at something very circular here. So this area is 80 square meters. Then you want to have one footing here. That's why I'm drawing like also some structural axis. So then you will have 6 footings. How does that look like in elevation, for example? You want to have like some nice leaf roof, and then those footings and those columns are going to land into a foundation. So 2 different columns will share one footing. So the way that we calculate the loads and the way that we try to calculate how the roof will behave, imagine that it's raining. You have this roof, it's raining, drops are falling down here, and where the water goes, you will have like some elements, maybe you have a post and beam structure here. So the drops will try to, the drops will fall down here and they will run down. So as the arrows that I'm drawing now, the water and the loads are gonna be distributed to those elements. So water will go here and distribute it to this foundation. Water will go here and distribute it to the other foundation. So that's how the loads will behave. Now, let's think that that you have your beautiful pavilion here. Columns, you can have like some trees, etc. Imagine like a beautiful and nice pavilion there. So all this area that is the roof, we're looking at a roof area that will be bigger than the floor area. So maybe if it's just 80 square meters, the floor plan, the roof area, it might be bigger. So maybe we're looking at 120, for example, 120 square meters. Because it's like imagine that you try to unroll or unfold the entire roof. That means that if you unroll it, the size of your entire roof will be way bigger. So we're looking at 120 square meters. Now, how many columns we are counting on this beautiful pavilion? We have 2 columns per footing, so that means that we will have 1, 2, 3, 4, 5, 6 columns on each side. That means that we will have 12 columns. The entire load that we are calculating will be divided into 12 different columns. So remember, we were talking about the dead load, live load, roof load, and trying to estimate everything. So here's a calculation in a very simple way. We were talking about 80 square meters of the floor, right? So that's for the dead load times 30 kg. That will be 2,400. What's the live load? People, furniture, maybe vegetation or some pots or some plants that you have. Let's use a live load of 100 kg for a residential standard thing. So that's times 80 square meters. Then we will have 8,000 kg. The roof load, we were calculating the amount and the size of that roof. That is 100 square meters. And then let's think that we're using alang-alang, we're using thatch roof. So remember that we were calculating that around 20 kg. It's not that heavy. So at the end, we will have another 2,400. What's the total estimate when we add all these 3 big guys? Our total estimate load, calculating dead loads plus 8,000 live loads plus all the roof, we will end having 12,800 kg, right? Correct me if I'm wrong, if you are following. So we have 12,800 kg. That is the entire load of our roof. If we divide that into 12, that means that each column will be able to hold 1,067 kg. How do I get to this number? Easily, having this 12 divided into 12. So each column can bear and can support 1,000 kg. It's doable, it's perfectly normal. A Dendrocalamus asper can support that and can support even more. A couple of bamboo bundle in Wadwa in Tali can support this weight. Remember, we are just using easy rafters, alang-alang, thatch roof, so it's very simple, it's not a lot of weight. Now, how much weight or what's the load that can support or that will be supporting each footing? Remember that we have 2 columns landing in just 1 footing. That means that 1 simple footing will carry double of this, meaning that 1 footing will carry around 2,000 kg. So those are the elements, and that's the rule of thumb that we usually use just to be sure that we can calculate and we can work on a foundation. Now, we already talked about the footing, we already talked about the foundation, the concrete itself. Now, what's going on top of that? Remember, we were saying the crown stone, that will not add a lot of weight, so don't worry about that. But then the next important thing is to think about how big it will be in relation to the bamboo clump, the bamboo column that you are using, or the type of column that you are using. So a skinny foundation under a fat column is very unstable. If we try to think that as a section, and then you have a bamboo here, remember always finishing a knot, you want to have a bigger foundation. It's not that you are trying to have your bamboo there and then having a very thin. So The other thing to think about is that we are talking now just one bamboo pole sitting and landing on the concrete. So having your concrete here, that means that in a floor plan will look like that. But if you will have more bamboo poles, then whether one, for example, having two bamboo poles here. Then you will add a gap and you will add a little bit of space on your base. So there's another important element that we have been talking about in terms of the foundation. Once you put the foundation and the bamboo pole inside the rebar, then you might think how it's stable, because it can be wobbly, it can move a little bit. So you will open a small window, and then from that window, away from water, that's the crowning stone. Bamboo loves moisture when it is alive. You've seen that it's like pulling a lot of water. But as a building material, water is our worst enemy. So a nice tip for you is always raise your bamboo at least 15 centimeters above the ground. Use stones, use drainage, use something and some other layers to avoid contact and direct contact with the water. But there's a tricky part here. Think about the finish level of your floor. So because you're going to start doing the foundation and you're going to start doing the concrete, then the level of the floor and all the layers for the finishing will add on top of that. So that's why you can see some extra space below that we can pour some lime floor or concrete floor there, and then it covers it up. So think about your lifting and raising the entire project 15 centimeters at least. You will see many of our projects that we have even more, almost like 30 centimeters, 40 centimeters, 50, 60. So by raising that above the ground, then you will be safe in terms of moisture. So here's a bonus for you in terms of the foundation. It's another type of joinery, it's another type of foundation that actually gives you a lot of opportunity to play with the angles and to work with splits. This is an arc, this is a laminated split that is getting inside a steel plate that actually allows you to move and to have an articulated joint. You can see that it's connected directly to a steel plate that it's kind of like hugging and just squeezing it a little bit, but it allows you just lose the bolts, then it will give you the opportunity to play with the angles. This is something that we did in the playground that we're building in the Kukul farm, and the previous sketches were like that, having like two different components. One is inserted into the laminated split, and then the other one goes directly to the concrete foundation, and then they are tied just by one bolt. So think about two different groups. This is the first group that will be inside the concrete. If you look at the section, is that steel plate that has some anchors going down into the concrete that then somehow with this steel plate, there's a small drill here. So this particular drill that is going in this direction needs to meet the group B here. That's where you're gonna put a bolt, and that will allow you to articulate the entire structure. Then you will try to open a gap here in the laminated split, so then you can insert that split, laminated arc into the group B. Once you have like those two elements in place, then you just put inside the group B with the splits and bolt it. Before you tie it, then you will find the you will find the angle. So because you might have like your arc with all the splits here, having the anchor point, this will allow you to go in this direction, but also in that direction. Once you find the real position of your arc, then you tied it. So that's it. With these simple principles and little attention to detail, your bamboo building can stand tall for decades, can start firm, dry, and very, very proud. So grab your sketchbook, keep your feet on the ground, and thanks for tuning in to Bamboo U YouTube Live, and see you in the next session.